More than me, perhaps not more than Henrik, but certainly more than me at least.
So you were more a band guy than a soccer guy?
Yeah. At that time, definitely.
That's like 12, 13, 15, that age? Or
up until, exactly. Up until maybe like, no, even up until university, I still played a lot of instruments, I think. So,
cool.
But mostly like guitar and bass guitar and stuff like that.
And what repertoire was? Were you rocker or were you? What was your sort of genre when you were 15?
When I was 15, it was more like that. I used to play in a band called Clown Butchers. So
that must be grunge.
That was more grunge, yeah, exactly. And then, but then I moved more into kind of pop and indie pop style of music. Yeah.
And then, like we all. Sometimes life comes in between and we stop playing. And now... Yeah,
exactly. That's essentially what happened. And then during COVID, my wife's brother lived with us for a while, and he was playing a lot of kind of a keyboard and synthesizer. And then I just felt that it was a very interesting thing. So I wanted to start doing that as well. And then I bought my first synthesizer.
And is this a combination of wanting to get back to music, but then also the the whole electronic or synthesizer phenomenon?
Yeah, totally. I've always loved like electronics, and I studied physics, so like that already from there I had that interest, I guess, and kind of understanding how circuits work, and I've done a lot of kind of small soldering projects, building small robots and stuff like that before. So it kind of felt very natural and interesting to me, yeah. So that's like music and signals converging, right?
Nice.
Yeah.
But now the nerdery starts. So okay, you're gonna buy a synthesizer and you have an opinion about electronics and like music. So how do you think about what synthesizers you should pick up now?
I wanted to go like analog, right?
You wanted to go analog?
Yeah, so I bought. You mean now, or meant the first synthesizer?
The first synthesizer.
Yeah, the first synthesizer. Well, I wanted to buy an analog synthesizer. I didn't really know. I did some research, and then I found this kind of mini Moog copy from Behringer called.
And what is a Moog?
Like? So Moog is like a super classic synthesizer that has been around.
And when was this golden era for the Moog?
Oh, it's early.
It's like Depeche Mode.
Yeah, like exactly everything. Everything from like Donna Summers forward, right? Like, so.
And why analog? What was the intriguing part? Because to go a little bit, I guess, vintage in terms of how the sound is made.
Yeah, I don't know. I kind of I like the sound of it and the kind of natural feel to it. I think there has been a wave in general that it's kind of getting back into fashion, right? People like the grittiness of it and the kind of the live feeling, instead of the more kind of harsh kind of FM tones from the digital. But I like combining them. I think that it's cool to do both, like doing weird kind of digital stuff and sending it through analog filters or something. Yeah,
because
that,
right? The keyboard that I bought that we have now here in the studio for the after party, nice. I went cheap, right? So I went completely digital, but has really good sampling of the old analog sounds, right? But that's not the same, right? I'm cheating.
Yeah, you're cheating a bit. I think
it's a price point topic as well. I must point out.
Yeah, totally. And I think a lot of the sample based stuff is super good. It's more about that when you start wanting to really transform it, then it either needs to be computed in real time.
So I can't really do it because you can really experiment with the analog waves of the sound.
It's like a wave signal, right? I even have an oscilloscope, kind of when you can.
Okay, so you started building your modules on top.
No, I'm not. Yeah, exactly. I'm buying modules and kind of connecting them together. I'm not building them yet. We'll see.
Do you mean you have a proper analog oscilloscope with you can actually see the waves and frequencies in it?
Yeah.
Oh, really? Yeah. Oof, that brings you back to
this is cool stuff, days. Right? So, how does that work? So you have this, you have the bass sound in the synth.
So you have like an oscillator, right? That essentially does some kind of waveform. It could be like sine or square or triangle or whatever, right? And then you can kind of do different things with that. So the most classic thing is to send it through a filter and a VCA, a voltage controlled kind of amplifier that can kind of lower and raise the volume based on your signals, and then you have some kind of like way function that is applied to that. So for both the filter and the amplifier.
So how does it work? Like you have your synthesizer, and you sort of have a way to get the line out from the core sound in the keyboard into the.
Oh no, the keyboard is actually just like a control signal, right? So
right.
you have a voltage coming out of the keyboard that essentially is plugged into the oscillator, which then controls the key, right? But then that would only be like bah, bah, which is not very interesting. So you need to do something with that. And that's why they have the kind of amplification and the filters and stuff to kind of wow, depending on. Very nice sounding.
So cool.
Yeah.
I think it's funny how, moving from analog, old style kind of instruments to more digital sometimes have surprising effects, like electric guitars, for example, right? In the beginning, they didn't really sound like a proper guitar, so to speak. And they had this kind of, what do you call it? Distortions or
pedals, all the pedals you have for different.
I mean, when you play the electric, it makes a specific sound.
The pedal stuff is very similar to this kind of component thinking, right? Yeah.
But I was thinking more like, it actually does not sound properly like a proper guitar, but after a while, it actually makes. It has their own value. So there is a point of having that kind of sound coming from an electric guitar. So going from a distortion or something that you don't want to actually being something that you do want to have.
Yeah, but
right?
and the electric guitar has several set of microphones, and those microphones has different. There are different styles. You have the humbug microphone or humbucker or whatever they are called. I mean, like different styles, and then you set them and how will this microphone pick up the sound from the pinging the guitar string, and all of a sudden now, when you have 2 or 3 different mics that are picking up the sound from different parts of what you're doing, you set to more and more treble or bass, whatever, distortion and stuff like that. You're creating a new sound. So you're not hearing
you're essentially creating your own kind of oscillations, right? With the string, and like that's very similar to what the oscillator module is doing.
So the original Telecaster from 54 or whatever that is, the Fender Telecaster, when they started, it's the first part of that, and then you have all the guitars, the electric guitars, has different variations on that, and then on top of that, you start adding your pedals to do even more, right? The wah-wah pedal, right?
Exactly, or a delay or a reverb. Or something, yeah.
So, to be honest, I've heard people play guitars with a pedal that makes that what you're playing into complete synthesizer sound. So you can almost get to, I can't play the keyboard, but I want to have this kind of electric sound, and you don't even know it's a guitar anymore. But it has a very distinct.
I've seen people on YouTube do that, like with play electric guitars and then put it into modular synthesizers and kind of fuck up the signal, right? It is super interesting. I haven't really gotten to that yet myself.
If you're a keyboard bass player, a guitar player, you need to merge these two things.
Yeah, totally. Totally.
Well, then AI is coming into synthesizers as well quite a lot. What was the name of this Google Magenta thing? The N-synth or something?
Yeah, exactly. Yeah,
right.
Yeah, I haven't tried that, but
it was some what was it? It was some kind of.
There's some kind of like screen with essentially different embeddings, I guess, and then you kind of morph between them, which have different kinds of feel to it.
What's the purpose? What's the
generating music?
Generating music
or sounds, yeah.
So you can have like samples being generated by the AI in some way.
Yeah, so I think you can have like samba in one corner and something like pop in the other, and then you can kind of merge between them in some way. At least that's how I interpreted it. Right?
Yeah. I mean, it's like another way, I guess, to just on the fly generate kind of samples that you can play with in some synthesizer, I guess.
It's pretty cool, actually. Yeah.
We're going to have a good after work today.
We should buy that. We should have that here. Right?
Yeah, I mean, like I got excited now because I have a keyboard. I need to get some of that shit.
Yeah. We did a hack day project once at the EQT, actually doing like trying to generate music from or sounds from like data that we had in our database. It mostly made really weird sounds, but yeah, it was interesting.
It's like the guy from Spotify one back in the days. He released an album called Sounds of the Office. And he just went and recorded different stuff like the coffee machine or the toilet, and flushing, and it actually became a super popular album.
That's pretty cool. That's a weird idea.
Cool.
Yeah, you could put that into a synthesizer as well. Like flush,
yeah, totally, and then you can play with the flush.
Yeah,
awesome.
Yeah,
Vilhelm. It's true pleasure to have you here. We met in a couple of times in the past, and you have such an interesting background, and what you do today is extra interesting, I think, for many reasons. But how would you describe yourself? Who is Vilhelm von Ehrenheim?
Ehrenheim, sorry.
Ehrenheim.
Yeah, it's all right.
Thank
it's all right.
Sorry,
everybody gets it wrong.
Ehrenheim.
Yeah. I mean, I'm kind of a data science, data engineer, kind of a person that has been kind of interested in AI and machine learning and data for a long time. Of course, I didn't know that at the start. I started like studying physics, and I thought, quantum mechanics and that kind of stuff sounded interesting. But then I quickly kind of realized that I really liked algorithms and statistics, and then it kind of naturally led into.
I have to just ask, what do you think about quantum computers these days? Is this something you're interested in? Is it something you believe will have a big impact? What's your current?
Well, this is a very, very interesting question. I'm definitely interested in it as a concept. I don't think I'm following it enough to kind of have an expert opinion on it, but it's super interesting. I definitely think they kind of have a role to play if some of the kind of physical limitations turn out to be solvable. Yeah.
If I ask you a very simple, small question, let's say that you had 100 billion euros to invest.
Wow.
From a European Union kind of question, and you have to choose. Now you can choose to conduct research in AI or in quantum computing. How would you invest the 100?
I think I would do it in AI.
100% or
all of it, 50-50?
No.
We would do all of it.
I didn't know you were allowed to split it up, but then maybe a bit splitting. Yeah.
But you're not allowed to split it up. All in AI. Good.
Potentially, some kind of merge between them too. That
exactly.
Yeah.
But isn't it?
But this is a real question, by the way, yes. and I actually do not agree with how some of the current investments in upcoming EU research programs is being made. So it is actually a very relevant question, and I think you answered it correctly. Perhaps not 100%.
No, 99.
Yeah, exactly.
But they will merge at some point, of course.
Yeah. I think
that's.
But aren't we talking about what time horizons to invest in? Because quantum computing is like, okay, I'm putting up all my money on the third horizon. Maybe
it's like
we need
only trying to solve the climate crisis with fusion, right? Or something. Yeah.
I mean, it's also a question about, we can easily see AI is of practical use today. It's so easy to see from the tech giants and so many other companies. But there is not a single, I would argue, practical use of quantum computers today.
You have your physical limitations still that you need to solve.
Yeah, exactly. You have some basic algorithms for solving some smaller problems.
That's a small problem on decoherence and other things and scaling them up. That I actually have my own
small problems.
I have my own theory about that, but let's not go there. Okay, sorry, but I think it's an interesting.
That was the first rabbit hole.
Yeah.
So for the producer Goran, 2 minutes on quantum computing. Stop.
Nice.
Cool. Okay, so you studied some physics in Lund, right?
In Lund, right? Yeah, right? Exactly. Yeah.
And what happened after that?
Then I started dating my wife and moved to Stockholm, and needed something interesting to start working on, and I started at Klarna.
Right. Oh, you started at Klarna. Okay, cool.
And
what year was this, by the way?
Was it? You probably have it there, like 2013 maybe or something like that.
Yeah, we had some friends from Moduli here in the podcast, and 2 or 3, 4 or 5 episodes gone. Good after party, by the way. Thanks, guys.
I can imagine.
I had to leave, but I think it's about the same time, right?
Yes, exactly. So I used to work with Eric there. Okay. He was already working when I started, and he was there when I left. So I had like 100% overlap for me with Eric. So but we worked in the same team.
So you work with credit as well?
Exactly. I work with credit risk. Yeah, exactly. Yeah. And kind of understanding how to apply machine learning to that problem and what we can do with data, and kind of crunching a lot of numbers.
And we actually didn't ask Eric in full. How were you organized at that point in time in Klarna?
Right. We did a few reorganizations during the time we were there, but essentially kind of we had one team that was first called like applied analytics or something like that, and then changed name to predictive modeling. And we were doing primarily the kind of models that try to predict the risk. And also kind of course, all the feature engineering and stuff that goes into that. And then we had an engineering team that working close to us that kind of helped us with the implementation and kind of moving between, like merging the batch and the real-time layers and stuff like that.
And I have a small angle on this question why I asked it, because fresh from the last podcast, we had Anders Nyman in Spotify, and we talked, I mean, he's engineering manager for Search, right? Which is one of the most the coolest team in Spotify, you know.
Yeah, of course.
I said it. Don't blame Anders. I think so. But we were talking then about, you know, what's the difference between the feature team and the platform SRE teams? Did you have the same kind of thinking around that? Or were you completely full stack responsible for the stuff you were doing?
No, we were not completely full stack responsible, and we had a lot of kind of organization issues around that at some point. I mean, there was a lot of things that went into a credit decision, right? So it was not only the models, it was also kind of the decision policy on top of it. Like, given the risk, how much risk do we want to take in regards to how much like we think we will earn on this purchase and so forth, right? And then there's also a lot of other kind of angles to it, like understanding then kind of where all the data comes from, and also kind of what the impact would potentially be when you release things and change policies. So there was a lot of different kind of teams involved in releases, which is not great from a kind of continuous delivery standpoint. Yeah.
Many teams is friction.
Yeah,
whether you like it or not.
So exactly. It was not like these kind of cross-functional teams. It was more separate teams that have their own.
Yes, at that point, I know that I've changed. We did like some reorganization during my time there, and then they did another one after I left, and now I think it's completely different. So, but
it's not easy.
No, it's definitely not easy. We do like, you know, all of the models that essentially did the same thing for all the different geographies, and just like only focusing on those things. Yeah. But we were also very involved in the decision policies and kind of simulating things and, you know, all of these.
But did you have engineers as well in that team, or was it main? No, okay.
So but they were like a sister team, like sitting next to us, so kind of helping us with.
I mean, that would be an interesting question as well for your current company as well, in how to organize as data science versus engineering, etc. So let's keep that on
as a topic on its own, where we can draw conclusions from different parts of your career and our careers.
But also Klarna is, you know, one of the top, I think, startups, if we call it that, in Sweden, and it's extremely successful in various ways. Why do you think it worked so well for Klarna? Can you think of some reasons for the success it had from a monetary point of view?
I think they solved a lot of the friction in regards to that's essentially their slogan, right? They solved a lot of exactly. But I think they did solve a lot of the friction in online payments in different ways over time, right? It has kind of evolved into what it is today, and that's also kind of embracing that change and really kind of riding the wave of simplification. I think it's like super smart, and that's something that they have done really well.
But I would take it one step further. I would argue, like a disruptor, that they are raising the bar of smoothness that we are expecting as an hygiene factor.
Yeah, that is true. Yeah.
And what we are doing today, you know, when Klarna started to do it in Sweden, you know, it was off the chart, you know, in terms of what is now, that's how it's done, right? And so I think
I totally agree. I mean, before that, it was very,
but
very
weren't they also they were sort of, you know, from a regulatory point of view, they were sort of pushing the bound. I mean, like I think some of the stuff we are doing now was almost not really possible regulatory 5 years back.
No, totally. Yeah.
Could you claim it would be more of a data-driven risk analysis, real-time risk analysis that they were doing that perhaps traditional banks were not doing?
No, totally. I mean, that's definitely the case as well. I mean, when you look at how a credit card works normally, that's like assessing the risk on a credit card is not a new thing. That's been around for ages, right? But Klarna kind of split it up on the purchase level, which gives you a lot more data. Right. Then you know exactly what they're purchasing at which time of day, and like.
But this was not done in Sweden before Klarna, in my opinion.
No, definitely not. That's what I was definitely a new thing. And then again, I think you can take a lot better kind of decisions then, given all of that data, and be more kind of surgical in your way to handle the risk.
So going more granular and trying to understand that from a more real time, I guess,
with data and AI,
real time purchase decision.
Yeah. With data and AI.
But can I ask you? This is a little bit loaded question. How much would you say the whole analytics around credit and credit risk is part of the core of succeeding with this business model?
Well, this was where I was working and thought was the most important in everything, right?
Loaded.
Yeah, very loaded.
So you thought you were working at the core.
I was it's core. Probably a lot of people that are in the core of a company, but
you were definitely.
I was definitely in the core at the time, and but I think that's definitely not everything. If we only did that, Klarna would definitely not be what they are today. So I think like having a nice kind of product orientation and understanding like market fit and kind of driving marketing and all of those things are super important.
But maybe we could do like the top 5. Like credit analytics is key. Market fit and the marketing has been absolutely brilliant.
Yeah,
and I think
totally.
And that has to be something.
Especially since I left, I think.
Yeah. and then maybe even the UX and the experience, how smooth it is also. I mean, like.
Yeah, that was already there.
The product interface is actually really important, I would say.
Yeah, totally. And exactly. And that was kind of a smart move they did early as well. Like instead of pages having the whole checkout experience kind of owning themselves, Klarna kind of took that upon themselves to make it nice, right? So, and it was also easier for the merchants to just have like an iframe or something. Just kind of.
And before we leave Klarna, I just have to ask a question from a more technical point of view. Having worked with Erlang, for example, myself, in Campania and other companies,
right.
What do you think about the tech stack in Klarna and the switch they made perhaps from Erlang to other languages? Were you involved in that in any way? Or?
It was definitely not my decision, right? But I think Erlang was a pretty cool language, and in regards to kind of handling a lot of traffic, I really understand the rationale behind building it in Erlang in the first place. Also, if you want to do it in a cool language and functional and everything.
How would you describe Erlang, by the way?
So Erlang is like a functional programming language that's kind of geared towards parallelization really well. So it essentially has a message passing system built in the kind of language itself.
And for people not familiar with airplane or with the different languages, but has heard about some of the other bigger languages, what level would you argue similarities for Erlang to other well-known languages?
It is a bit different in regards to it kind of being, first of all, being functional. So functional, there's a whole kind of world of functional languages. Like you have Lisp, right? Or the kind of original functional ones, right? But then you have like Haskell and OCaml and like there's a lot of them. F#.
So we are talking about first. I'm the newbie, so I'm trying to understand this with having no clue. So functional languages is like one bucket here, right?
Yeah, exactly. So in a functional language, you essentially have a function as the first class citizen rather than having like a class or an object. So then you can kind of save functions and make functions of functions, and it's essentially it. So and then so that's one part of Erlang, and that's a whole kind of language class, right?
So functional language class is the first, and what do you? Okay.
And then the kind of what's special for Erlang is this essentially, first of all, it's a very kind of limited language. You have very little kind of apart from this then message distribution kind of idea where essentially you can create actors. So the whole idea and the kind of have small actors that does something, and then you can send messages to and from actors. And then that kind of lets you parallelize things in a very easy, nice manner, because that's essentially what you have to do if you parallelize things over like between machines or in larger networks, right? So you just do that by design up front.
But is it like, as an idiotic question now, if you go down the path of a functional language and with its limitations, it kind of drives you into a philosophical path of how you code or how you think about your systems?
Totally. How about there's an old friend of mine who used to say when we were studying in university, like I'm used to doing like Java and those kind of languages. You think for 1 minute and then you have to code for 10 minutes, right, to solve a task. Whereas when we started doing like functional languages, I think it was task at the time. It was like, I need to think for 10 minutes and then I code for like 1 minute. So it's like
very interesting.
Yeah.
Good.
I mean, I guess also, Erlang has some famous examples as well. I mean, you're trying to avoid, having side effects and it really simplifies, concurrency management when you want to do stuff in parallel and you don't have to think that much, at least about locking problems and deadlocks and live locks and whatnot. And they also have, what was it? It was Facebook Messenger that was written in Erlang, I think, at least at some point in time.
I don't know that. Yeah, maybe.
Yeah, I think it was.
It kind of makes sense, I think. Yeah.
I think they searched out.
And what happened? Where are we now? Leaving Airline and going where?
You mean language-wise?
Yes, in Klarna. In
Klarna. Klarna did a switch, which a lot of companies do. I think when you start looking at more kind of big data and things, that you start looking more into Java, right? Java is very well known. It's easy to recruit people that knows
Python,
Java.
But Java.
Oh, both. Depending on which kind of problems that you're solving.
And now the next idiot question: what type of language is Java?
Java is like the classic object-oriented.
So this is object-oriented.
Yes.
And how would we define Python?
I guess also object-oriented.
Yeah, exactly.
Less
but trying to be a little bit in between. Yeah.
Weakly typed, object-oriented.
Yeah, exactly.
But I mean, I remember when I worked with a problem with Erlang as well. We should mention that Erlang comes from Ericsson.
Exactly. I was
Ericsson language, right?
I felt that was missing from the discussion.
It's kind of a proud thing from Sweden, but it also had the problem with they had this kind of database. What was the name of it that they had in memory all the time? Amnesia, right?
Amnesia. Yeah.
And that was a problem, right? Didn't Klarna go into like a super huge computer, like terabytes of RAM?
That was definitely a large problem for them. Yeah. And kind of moving out of that was very hard.
But you need a lot of cash.
It was also not very nice from a kind of. I guess that depends on how you implement things. I guess it kind of grew into that over time, right? But when I remember my early days there, when I kind of when you wanted some data in order to be able to train your models and so forth, you needed to essentially to go and ask the team then for an extraction from the Amnesia tables, and you couldn't really do that like the way you like yourself, because you were essentially affecting the prod environment, right? Which is like
it's almost like the old nice. Alta Vista versus Google things. Alta Vista went super big mainframe, super large computers with lots of memory, and Google went parallel. And,
who won?
Yeah. It's probably only because of that.
Of course,
only
cool. Well, enough about Klarna, perhaps. But then you moved on from Klarna. What happened after that?
Yeah, then I joined EQT. I was actually contacted about that. It was a recruitment firm contacted me in regards to starting to be part of something called Motherbrain, which just the name kind of made me a little bit interested.
It's super cool.
I love the name as well.
It's a pretty cool name. Yeah.
I need to ask, what is your first idea that pops up when you hear Motherbrain? Because I have an idea that resonates with you.
Are you asking Anders or me?
Both.
I mean, I'm so colored on that, right? I've been working with this project for 5 years. So like when someone says Motherbrain, it's like,
I think mother. Of course, I think mother. And what is the reference mother?
I think more HAL 9000 actually, like the central kind of computer mother brain that serves
because
everyone.
I was thinking HAL. But which in one of the sci-fi movies, it's called Mother. I think that is an Alien.
Oh.
In the Alien movies, HAL. I was thinking HAL, but I forgot it was HAL.
It's actually an old kind of gaming reference, right? So the boss in Metroid is called Motherbrain, and there's also another game called Phantasy Star where kind of also.
But I get this sci-fi HAL in. What was in Odyssey of
2001 Space Odyssey,
or when you see, for instance, the Alien movies, they talk to Mother,
like a hive mind.
Or actually they refer to the AI of the ship. Mother, what's the status? Anyway,
so that's what I'm trying to build.
Motherbrain. So it's like Google's new thing. Did you hear about Google Pathways?
No, I haven't actually.
Oh, okay. Let's not go there. But it's like a super big neural network that is supposed to be able to handle 1,000 different tasks in a single model. Going super big, like a mother brain of all, or mother neural network of all.
Yeah,
in some way. So
sounds very interesting.
Yeah. Anyway, you went to EQT, and you were basically recruited there, or you had some headhunted.
Yeah, exactly. I was recruited. Yeah, I was.
What was the pitch? How did it happen?
I don't remember the exact pitch, but it was you get a lot of these kind of emails sometimes, and then I don't necessarily even read all of them, but this kind of caught my eye, I think, and that was the first thing. I was like, I think it was probably the name. And then also, I think it just sounded very interesting. I was modeling people who can't pay, in a way at Klarna, and I kind of, this pitch was more like, now try to model startups and what makes them successful, and it's kind of just really resonated with positive. What I thought it was nice. Yeah, exactly. Yeah. But
you started at Mother Brain directly, or did you work with some other stuff at EQT?
No, I started with Mother Brain directly. So at the time, the Ventures Fund, which is like the startup kind of investment fund in EQT, had done a kind of proof of concept, essentially building a small tool with some data sources together with a few consultants, or they didn't have any kind of developers in house. But then they got my boss then at the time, Daniel Wroblewski. And he employed me and a full stack engineer called Johan Koch. We were the first three to start kind of building it in-house.
You were the first three as well.
When you got hired, or what was the sort of mission with the 3-man team? So what were you setting out to do?
So first we were kind of just trying to understand the kind of sourcing within ventures. So sourcing is essentially just finding interesting leads that you potentially could invest in. Right?
But perhaps we move there. I think we need to have people that don't know what EQT does understand that a bit more.
EQT is an investor. Right? Yeah. We have a lot of different funds that do invest in large, different sizes or different kind of ideas of what companies do. And it moves from like being ventures is doing like small startups. And then we have a growth fund doing like larger startups. And then we have the larger buyout funds, which essentially buy like a majority share of a company and owns it for kind of quite long time horizons and try to be kind of part of making it better. And then we also have infra funds, which is like doing infrastructure investments, obviously by the name, and also real estate and stuff like that. So
So it's an investment company that has everything from startup VC to growth VC to
which is pretty unique.
Which is a chain of different types of investments.
Yeah, exactly. Yeah.
And I guess they have the problem of they need to know which company to invest in.
Yeah, totally. And especially like earlier than especially from the ventures side of things. I think traditionally how you do investments is that you have a large network that you kind of rely on. And then you hear something, or you kind of go to a conference and understand and learn more, and you rely on people coming to you and asking for money and so forth. Whereas some of the partners then in the Ventures Fund were coming from companies like King and Spotify and so forth, and they were more used to doing data-driven stuff, so they wanted to do that investment. That was kind of the idea, right? So this was kind of core to when the Ventures Fund started. It started just before kind of like a year ago or 2 years ago before I started. It was very new when I started. Right?
So basically they started their own startup.
Within the investment company.
And the core problem that Mother Brain is trying to solve, how would you summarize that? What is the core use case?
Well, I think originally it was only the sourcing, right? Sourcing is turns from under like finding interesting companies.
Identifying from a gross list to a short list of interesting investments.
Yeah, exactly, right. And I mean, there's thousands of startups started every day. You can't really follow all of them and understand. And so having data on kind of how they're growing and who is moving where and, all of these things is definitely super beneficial. So the kind of original then problem is to sort and rank those companies and have some kind of prioritization.
Sort and rank.
Well, that's the same concept, I guess, depending on what you sort on. But if you sort on the rank, then very much. But essentially giving the deal team a way to kind of prioritize between different things, and also find interesting ones that they wouldn't otherwise see or hear about until it's too late.
That was the core. That was
the core. And then quickly we kind of realized that we need the intel from the deal team, what's actually interesting, right? It's super hard. Like, if you just get that question, you need to ask them, and then you ask them a lot of questions. But we realized that we need to get this more in a more kind of automated fashion, right? We want to be part of their decision workflow. So we started building more kind of CRM-like features on top of our databases, where both we could kind of present the findings that we had and data and analysis, but also then let them kind of progress deals through their funnel and then feed that back into the algorithms and train them on.
So you get the false positives feedback loop happening in some ways.
Yeah, exactly. Yeah, and also kind of the true positives, right?
And the true positives. Yeah. So you basically you're building in by connecting closer to the deal workflow, you're feeding back.
Yeah, essentially get the deal team to label data for you, right?
It's great. Smart.
And that when they do that, and that's kind of natural to their work, then the algorithms improve, and they think it's better, and then they use it more, and then you start realizing that there is a lot of other potential. You could kind of expand on this original use case and make it bigger. So like do have more data on how companies are kind of working and how they're growing and those things, and then also kind of starting to understand like, okay, then it's interesting to look at groups of companies as well. Like, how are they evolving? And could you find similar companies? Yeah, exactly. Right. Mm-hmm. So could you find similar companies to this one, which is the super relevant
analysis
kind of, yeah, exactly. So that's a huge, very common question that we've had over the years. Like, people just want to have similar companies. I have heard about this company. Do we have any other similar companies doing this?
Yeah, we lost the race on this one. What's the next one?
Exactly.
Okay, so it would be interesting to hear more, what type of data, etc. But if we just move back, I guess, in the beginning, before Motherbrain existed, the deal team has to basically do that manually or through tips or whatever data they could manually find and review. And then they want to have a bit more automated way in trying to make the decision, I guess. But it's still not like fully automated. And please interrupt me if I'm wrong. And then in some way you basically want to have AI in as a service for humans in some way. Yeah. And one thing that we've said a couple of other times, and it would be fun to see if you agree, is that AI and humans are good at different things. So AI can be good at going through a huge amount of data, like the thousands of startups that comes every day. Yeah. No human can keep up with all of them, of course, but an AI can. But it's rather superficial in a way. It actually evaluates the company, but at least it can flag and highlight and suggest some kind of companies to manually review more. So you can at least remove the horrible companies directly and focus on potential candidates, right?
Yeah, exactly. And find the hidden gems, which is like essentially the core idea of a ventures fund, right? You kind of maybe invested in a lot of small companies, but you don't expect all of them to succeed. You kind of expect a few of them to succeed. So it's very important to kind of find the interesting ones. Yeah.
But I think the question is, isn't this an augmented intelligence type setup, or were you going somewhere else?
I think in my experience, at least, the best examples of how you should use AI is together with humans. So let AI do what that's good at, which is going through a huge amount of data in some way, and do some kind of highlighting or suggestions, but keep humans in the loop in some way to do the final evaluation. And
we have there's always people kind of joking about us trying to kind of
compete.
Exactly. Kind of make the deal team redundant, essentially, right? But that's not necessarily the way the team looks at it. Our kind of vision is to give our deal teams superpowers, essentially. Right? So, which I think is essentially exactly what you're saying.
Yes.
But the symbiotic approach here, the augmented intelligence, I think you're cementing that when you use the human as the labeler.
Yeah.
Isn't that smart? I mean, because it means this is a real reinforcement loop where the human interaction is not only we are helping him as the superpower, but he's then feeding back to the computer what worked. I think that's really brilliant in a simplistic way, right?
Yeah, but But labeling all the time is done by humans, more or less, right?
No, but I mean, like the whole. Yeah, maybe I'm exaggerating the importance of it, but I really
Sounds
think.
good.
No, but I think we are. How many times do we do something and we feed something from a CRM or something into the sales guy, and the sales guy say, "Oh, this lead is shit," yeah, and they say that and they keep complaining, but systematically there is no feedback loop on the shitty leads. We're just complaining to marketing, and you would be surprised how many companies are truly systemizing the feedback loop back. And I'm not even talking about machine learning now. I'm just talking about broken processes, completely broken processes. So from this regard, I think it's a fairly big deal how you're actually using them as part of.
I think it's super important for us, our success over time as well, because these people are like, they're of course my friends in teams, but they are super busy. Like we don't the deal teams should be focusing on kind of finding and making deals, right? They shouldn't be focusing on labeling. They don't have the time for that. They're also super expensive people. So and it's also very hard to kind of offshore labeling effort because they don't know what's interesting, right?
So you need to really interact right at the right point in time where the labeling, when they're doing their work, it's not extra work, so you just get it done.
Yeah, it's part of their process. Yeah. They need to do that in order to progress the deal, right? So it's like even more integrated into their process now. So it's part of how they are communicating with each other within the team. And
it's moving to, if you just throw out some buzzwords here, and I shouldn't really do that, but you have the traditional CI/CD kind of things where you want to have continuous integration, continuous delivery of software development, but then thinking more of an ML ops kind of situation. You don't only want to have continuous integration and continuous delivery, you want to have continuous training as well. So you continuously update the model, given feedback when you interact with the system. And that sounds like something you're doing. Sounds right.
But there are two major topics here. You took number one now, that you're thinking ML ops, and you're thinking how you actually feedback loop to completely continuously adjust the model. The other key aha here is that what you're saying is that it's not enough to have the model. I need to find a model that I can embed in their salesman's, or now in the deal guy's workflow. So you become data AI software thinking. You can't only think model.
No, exactly.
You can't do model without data.
No, it's
and actually you cannot do this. Mother brain to succeed needs to be in part of their workflow, which is basically whatever their software workflow system they have.
Exactly.
And you call it CRM, basically, but it's not CRM.
It's not CRM.
It's their type of workflow.
It's a deal-making platform.
Yes,
that's what it is.
So now we have my argument that the transformation is about data, AI, and software. And you can't, if you truly want to be an integral part of a core process, you can't really do AI without software or data. That's I'm trying to force.
That's exactly what we're like. We're also not only like data scientists or ML engineers, right? We're a mixture of people, like everything from UX and full stack.
That's the point. So people think you can have a central data science team do magic, but wait, what's the software dimension? What's the data dimension?
I think the UX dimension is so important because that's where people who consume the insights are actually kind of. If you can make that process, understanding the analysis and the kind of integrating that into their way of thinking about the problem, it makes it so much more powerful. Totally. Without the UX, it would not be what it is today either.
So augmented AI means really important understanding for how can I take complex algorithms and present them so it fits with the workflow and the level of data literacy. For whatever role you're working towards.
Yeah, and really solves the problem for the consumers as well, right? Yeah. It should not just be kind of slapped on in order to kind of try to do it.
And when we talk about it now, it's so obvious. Yeah. But then we have a data science team on their own and they're supposed to do magic. I think this is quite important lesson.
Yeah, totally.
Awesome. Should we move in perhaps a bit more how it actually works, look into the brain in some way.
Let's go here.
So I guess the manual deal team people have their way of evaluating companies.
Totally. And it's a slightly different depending on which font context you're looking at. And there's different teams, but there is also different kind of ideas of what's interesting and that kind of made us organize that way. So we need to really kind of understand the process and the way the team is working. So we're kind of have dedicated teams working towards the different kind of fund contexts.
Okay, so it's different approaches for different funds that you're taking. Okay, I realize so you can't divulge everything, but I'm happy to see that you actually published a paper as well, so we can speak more about that shortly.
Yeah, sure.
But as much as you can you just give some example or some overview of how does the actual brain works? What kind of data is it using? What kind of approaches do you take?
It's using a lot of different data sets, of course. And like some of it is part of us kind of scraping the internet, trying to find data. And some of it is purchased different data sources. And then everything needs to be merged some way. And I think if you're used to looking at public market data, it's very well structured. Everything is like super easy to use. It's like you have the stock tickers and identifiers, and it's just like you essentially merge everything and just do joins in a nice database. It's not necessarily the case when you start looking at more unstructured data, and the private markets are not very structured. It's very different in different countries and different in like everything is different. And also when you have different data sets, you need to kind of figure out which company is the same in these two different data sets. It sounds trivial, but it's not.
But data cleansing is actually a key topic
here. Right. So we do have different kind of jobs and pipelines and so forth, kind of downloading data from the different data sets. And then we are effectively running also machine learning models on top of kind of the merging problems, trying to understand whether or not it's the same company or person or funding.
We had the same problem in Spotify as well. I mean, just deduplicating the songs or the artist or the album was super hard.
That. Yeah,
it's super hard problem.
But what you're saying now, so I follow the stupid guy. We can do machine learning very early in the fundamental data cleansing, data quality, data duplication path as well.
There's one thing with kind of, you can do it to automate the kind of cleansing and outlier detection and stuff. Like we've got, like, for example, funding round at one point that was larger than the world BNP. Like that's obviously not true, right? So you can have them kind of outlier detection and stuff and try to filter out stuff. We could definitely be better at that, I think, though. But then when it comes to kind of merging, so we can essentially kind of just makes everything into a similar format and then try to join it based on this kind of machine learning model output, essentially. Yeah.
Okay, so you have data from scrape data. I guess is it from like databases about companies, or are you using social media as well, or are you
the kind of the base data sets are definitely around companies and who owns them and who works there and so forth. Yeah.
And are you using like news articles as well, or things like that? Or?
Yeah, of course. Not necessarily that much to kind of find entities. So we don't do that much like name them through recognition. We definitely could do more there, I think. Yeah. It's a super interesting area. We tend to kind of rely on providers for that. And I think part of it is because we need to do some kind of trade-offs in regards to where we put our efforts on the machine learning problems. There's like a bazillion ones. So if we do all of them, I don't think we can focus on all of them at the same time. So
of course. Good point. Cool. So you merge them, you deduplicate them, you clean them, and you get some kind of, I guess we have different models for different parts of this pipeline, if you call it that. Can you mention some examples of some models you're using to understand, I don't know, news articles, or how to do the final prediction in the end in some way? Or?
Yeah, so I mean, the merging models is some kind of like Siamese network that essentially similar to what you do for like face recognition and stuff, right? You kind of compare different things. We also have, of course, a lot of NLP stuff. Like we have a lot of texts. So we do that to classify the companies into a taxonomy that the deal teams are used to working with. And we also...
so it's if it's a media company or if it's a manufacturing company or whatnot and stuff like that.
But a little bit deeper kind of.
So NLP style, you can build up a taxonomy that allows you to categorize the companies in a way that the deal
Exactly. So EQT has this kind of thematic investor kind of concept. So they do kind of focus on different areas and try to really learn them and be part of those.
That's the taxonomy.
Yeah, exactly. So that's the taxonomy. Yeah.
And here we have NLP in order to sort what is coming into the right buckets.
Yeah, exactly. Yeah.
Mm-hmm. Super cool.
And what's the prediction in the end? What is the final output, so to speak? Or do you have
but it's different parts
or?
then. I mean, like it is a UI that the deal team can interact with, right? So the sector like we're predicting there is obviously, of course, there somewhere. We do actually predict like gender on people to understand to be able to see like, okay, if this is a female founder or if it's not, and what's the diversity in this team and so forth.
Oh, really?
We do.
So that's separate outputs.
So it's separate outputs. Yeah, exactly.
So being fed to the deal team that they can review later.
Yeah.
Okay.
And then
some kind of success score, or
yeah, exactly. That's what you're after, right? So definitely, there is this kind of ranking or score to kind of to tell you whether or not it's an interesting kind of company, and then that's a little bit different model architecture wise, because we do have a lot of time series data to take into consideration there, like. The number of employees over time, for example, or what funding has happened over time before, a lot of those things.
Have you looked into a bit more like feature importance kind of metrics to try to understand what
we
kind
do,
of data sources?
Like it's very common to get a question like, why hasn't this company got a high score? Right. And then you need to be able to try to kind of explain that. So we've tried it. We do, since we have a kind of an architecture that is a little bit multimodal. I think that's very hard to do in a nice way with multiple models, but we try.
Yeah, awesome. Yeah. Do you use some specific this is also a favorite topic of mine. So sorry for going a bit techy here, but but if you were to have text, for example, as an input, and you want to do some more explainable AI on that. Do you use some specific techniques like integrated gradients or some SHAP values, or do you?
We have used kind of what was that name you said last?
SHAP values.
SHAP values, exactly. Yes. We've tried that one.
Okay.
And I think it kind of works for some of the models where we have like more simple input. It kind of. It's not necessarily as important as the kind of larger models, I think. So, but there's definitely more room for improvement here as well, where we can explain more. But normally we've done a lot of kind of permutations and trying to kind of understand like what is the impact if you change this and that, which is essentially what SHAP values is doing as well. It's just more smart about it. Yeah.
I think it's an important understanding that people are a bit afraid sometimes to use this more deep and black box kind of models or deep learning models, and I think it's impossible to understand them. But in reality, it is possible, and there are a lot of techniques to do understand them. And I think you should always compare to like humans. And if I ask you why you think this company would be successful, I don't do that by looking inside your brain, right? I ask you to explain it, right?
That's very true.
And I think we should do the same for AI models. Wouldn't you agree?
Yeah, totally. I mean, it could be interesting to understand like what I could maybe ask you like, what's your reasoning, right? So that's probably something that you would want to answer or ask a model as well, which is essentially what I think we are trying to answer when we say like, but what if you change like the gender to female? Right. Is it still high score? Like, or
exactly. But I think that's the whole point we're coming back to, that you are not asking to look into the doctor's brain. You're asking the doctor to explain his reasoning for his prescription.
Exactly.
Right?
Yeah.
So why should we ask for something else from the system, right?
Exactly.
Yeah. Maybe a tricky question or sensitive question, or maybe not. What have you identified, or have you discussed the sort of the traditional, the classical AI ethical conversation around what you're doing and how it's not biased and all that?
So, especially the bias things.
I mean, this is classic, right? So we are doing something, and I think it's a really good idea. But how do we combat bias? How do we say that this is actually, and I mean that both from a core business perspective, good business for you guys, but also to get good startups with this diverse setup, their same shot.
Yeah, totally.
What's the conversation
It's a natural
here?
question if you go back to this feedback loop, right?
Yeah, exactly.
If you have a feedback loop, you're kind of enforcing the bias of the team, essentially.
Unfortunately, yes.
Unfortunately, yes. So that's definitely something that we have been working quite a bit with, and that's, I think it's super relevant for pretty much all models, right? Yeah. Because also it doesn't necessarily have to be kind of normal bias, but if you're kind of changing the definition of what you potentially want as an output, like all the data is stale, right? And that's not very nice. So you need to kind of figure out how to handle that and how to kind of backfill the labels in some way. And that's, so we have been doing, so the female founder example is great, right? If you only train on a history of investments where all the founders have been male, that doesn't necessarily mean that you want that for the future. No. So then either you can augment the data, so making it less kind of prominent, or you can start also looking at the history if you can kind of create labels from the history in some way. So looking at other successful deals that are happening. You could also kind of combine, like, I don't know if you're kind of familiar with Snorkel or kind of Watchful or tools like
Snorkel,
that. Yeah, there's this concept of weak supervision that we have been kind of working quite a bit with in that regard. It's also a way to expand your label set, right? So
weak supervision, that sounds super cool. I don't have a clue what it means.
So it's essentially a kind of on the onset it sounds a bit weird, right? You essentially define loosely defined rules, like saying that growth is good, like growth in employees is good, female founders is good, those kind of things. And then but if you do a lot of those, first of all, they don't necessarily overlap exactly with what you think is interesting. But if you do enough of them and decorrelate them and kind of combine them together, they should at least kind of represent essentially a labeled set, but weakly. And then you train a model on that, and then you look at the output, and you should of course have data sets that are more kind of thoroughly labeled as well, like golden sets, right? So then you can kind of understand, okay, where is my labels not necessarily representing what I want? Can I do more rules to kind of augment this and make it better?
Can I try to synthesize for me in my stupid brain? It sounds to me that in terms of working with bias and these kind of topics, you need to actively work on it. You need to actively combat. It's a little bit like you're on a convex, and the ball is trying to roll off. And you kind of need to always work on it in order to.
I think you need to do that with normal labeling as well.
Yes, yeah. But this is sort of, don't never forget that whether you like it or not, humans are biased. So if you're not combating bias vigilantly the whole time, your model will in the end be will not fly.
No, totally. And I mean, in regards to conscious bias, you can do things like this when you want to change something, but the unconscious stuff is of course super hard. So that's going to be super hard regardless, I think. Yeah.
I'm biting my tongue a bit here.
Please don't. This is a tricky. This is a hard topic.
Let's take the example of female and male founders, for example, and imagine that, historically wise, of course, it's probably been a lot more male founders. And then perhaps it's starting to come up more female founders, which is great, of course. I would argue that even though, if we just take this single feature by itself and think about how the AI model is being trained, unless there is actually some kind of information gain in looking at that feature, it will not actually look at the gender of the founder, even if it's been like 90% male founders in the past. So I'm not sure if I explained myself properly.
No, you don't. So I think I know what you're going. But
I totally get what you're saying. So like if there's only kind of one female founder in the history and that was actually positively labeled, like then it would probably be even more prominent, right? So
exactly. So the connection is rather to,
but the bias was there at the time. So I guess like the distribution of kind of female founders actually being marked as interesting at the time when it necessarily wasn't, like that's probably not going to be the case, right?
Yeah, I just think people it's easy to misunderstand and think of machine learning as pure statistics. in that way. And what I mean with pure statistics is that you just look at the historical distribution or all of the gender of founders and say, since 90% of them was male, then it must be good to be male. But that's not how machine learning works. I mean,
but this is the key topic that I really want you to explain, because I know what you're going with this.
Yeah.
And 90% do not understand this difference. So please elaborate.
I'm not sure I can. I will try. But you know, if you take traditional decision tree kind of algorithms or whatnot, they have this measure called information gain. It could be entropy or Gini or whatnot. But they are trying to choose, let's say you have 10 features. Gender could be one. Another could be age. A third could be category of something. I don't know. They are not going to pick the gender unless it actually has some kind of value to make the correct prediction. So if the prediction is this company going to be successful or not, yes or no, it doesn't matter if 90% was male unless it actually has some kind of informative value. So it has to be correlation between the gender and the success story for that feature to be selected and used at all.
You're totally right. Totally right. But like in the history where you have a kind of a bias inherently in say the decisions where whether or not to kind of invest in a company, you would then have a model picking it up. I think like that, because then it was not necessarily so that it was just less female founders. It was also kind of a bias against it, right? So yeah,
true. That's a really good point. So if there is like some kind of hidden bias, so to speak, and people were choosing male founders
over
consciousness,
yeah, exactly, consciously at the time, yes, exactly.
Then they potentially would be successful. Then it could be some kind of.
It's not only kind of the availability; it's also the actual kind of.
But I think it's important to distinguish it too, because
I totally agree.
Normally, if it's just looking at a single feature, the model is not that stupid. It just looks at the statistics of it and try to choose it in that way. It actually has to have an information gain to be selected by the model.
We had another kind of similar problem with bias at Klarna, which is like the selection bias. I think maybe you spoke about it last time. I'm not sure, but when you reject a purchase, you don't really know if it's going to be like paid or not, right? Because it never happened, and that's obviously a huge problem. You can only train on the accepted purchases. Like the better the model gets, you only see the good stuff, and then some for some reasons, maybe due to some process like error or something else comes through, or has and then maybe that was accepted anyway, right? And then was paid. Then it might actually look like a rule where you normally would never kind of consider to give credit would be considered good, because you kind of accepted and it was paid, but they had like 100 unpaid invoices. It's like because the few that got through there did not tell the true story about those that were rejected.
I mean, it's a classical feedback loop. I think,
exactly, right.
You could have like a search function in Spotify or something. If a person starts searching and clicking on the search result in a certain way, that will feed back into the algorithm as well, and that will reinforce that behavior.
But then when you started listening, it was shit.
It could be. I mean, these kind of feedback loops can be really dangerous.
Yeah, totally.
So
tricky stuff.
You have to, tough shit.
Can we move a little bit? What's the tech stack? What's the tech stack?
We're heavily on Google Cloud. So we're using everything there, like BigQuery, Dataflow, Bigtable, Kubernetes, Kubeflow.
Have you been able to go quite native in GCP, or have you, what are you working with that is not GCP services?
Kafka.
Why not PubSub then?
Because this was my decision at the time, and I think it still holds. It's kind of PubSub is nice for kind of distributing data between systems, but we were more looking to kind of decouple things in that regards as well. So we do use the compaction feature heavily in Kafka, which I think is actually available in PubSub now, but wasn't at the time. Right. And then also the kind of order of things were important, which PubSub does not kind of provide. And you also don't have the possibility to change the retention time, or you couldn't at least.
Right. But could we just unpack the tech stack, a little bit nerdy, from scraping and ingestion? What do you use in order to get it in? Or do you go straight into your core storage, Parquet storage, or you go somewhere else? Or how is this streaming? What is it, right?
Yeah, we do have a hybrid of streaming and then kind of batch processing, and kind of depending on.
So starting from the scraper, let's start
from the source. Yes. Yeah, exactly. So we do use Apache Airflow to schedule things for kind of
And you manage that yourself as well?
No, there is Cloud Composer which is doing that. We used to manage it ourselves in the beginning, but then when they released the Cloud Composer, we switched over to using that. Yeah. And then it essentially schedules, like we know every Tuesday every month we get this data source and blah blah blah. And then we have schedule jobs downloading the data and kicking off essentially processing, which is normally data flow pipelines kind of processing it into our kind of format and way of that, so that the kind of downstream
the data flow is the core way how you
data flow is the core kind of transformation. Yeah, exactly. Yeah,
but you don't actually take it first into your data lake storage of GCP.
Yeah, totally, we do. So the Airflow jobs normally kind of saves everything raw as well, of course. Yeah. It's super important in order to be able to understand where it comes from, right? So
into cloud storage, I guess.
Yes, that's cloud storage.
Their S3 kind of things.
Yes, and BigQuery actually as well.
Yeah, so this is the GCP S3.
Kind of depending on the source, right? If it's very nested and weird, then maybe not in BigQuery, but then we maybe kind of de-nest it a bit before we ingest it there.
Cool. And so basically you get it in somehow, and there are these kind of two different architecture. You can think about the Lambda architecture and the Kappa one, if you heard about them.
I think we're doing more Kappa style.
Ah, right. Really?
But the sources are kind of different and kind of coming in different kind of iterations or times or whatever you say. Like, and then it get processed, but then it feeds downstream into essentially where it's all merged and processed and put into our kind of data model, right? And that whole pipeline is streaming because we have so many different data sources coming in. We just want everything to kind of flow through the system once something happens. And the same goes for stuff that are actually kind of happening internally. So if a deal team is doing some labeling, or if they are kind of changing some values or whatever, that's also kind of fed as a data source, essentially kind of being combined with the rest of the data.
So should we understand the system as more or less real-time event-driven mostly, or is it more data at rest? Or
the events is essentially new data coming in, right?
Okay.
So it's not like a funding round happening, because that's not really how we get the data.
Good, because so how BigQuery, how does that come in here now? So
BigQuery is mostly kept for analysis.
Yeah. So when you're doing something, does it go straight into the sort of dealer CRM, if I use that word, or
exactly.
Production pipeline?
It's essentially kind of flowing through. We do have data flow then processing it. Like some of it is streaming data flow jobs, some of it is batch, but it doesn't really matter. The output is put into a single kind of same format all over the place, which is very kind of slim, essentially a log of change, right? Mm-hmm. And then we have a system kind of picking up those and joining them together from all the different data sources, keeping state essentially. So everything new that comes in is kind of put into this. So say that for some reason we get the name change of Spotify to Spotify AB, and then that comes in, and then that's kind of put in place into the state, given a lot of rules, of course, because we want to make the data better and more recent and so forth. And then that's output to Kafka, essentially the new object with the new data, and then that's fed to different databases and also out to BigQuery and everything.
And the state is kept in Bigtable basically, or yes. Yeah. Okay, so you have data coming in, it's fed to the cloud storage and BigQuery. You have a number of pipelines running on the data flow architecture. Mm-hmm. Are you programming in Java or Python, or both?
Yeah, that was my core question. What would you say is your language of this system?
You
said Kafka, by the way, and this is one part.
Yeah, exactly. But Kafka is more like a message passing part of it, right? But we do primarily use Java for most of the kind of heavy processing, But we have for different reasons have been running kind of TensorFlow models directly in Dataflow jobs for doing some of
so
this
that
more
is
kind of simple.
Python.
Yeah, exactly. That's Python things.
But no Spark.
Yeah, we do. No, we don't do Spark. We have done it for kind of.
That's the alternative to Dataflow.
Exactly.
Yeah. So Dataflow, for people, it's an alternative to traditional kind of Hadoop systems.
Yeah, Hadoop,
and
Spark,
it's a managed big data processing.
Yeah, exactly. It uses the Apache Beam kind of API, which is or SDK, which is essentially something that you can run on different kind of engines. So you could potentially run what we're doing.
But when you
Spark.
code in Dataflow,
we're coding in Beam then,
in Beam
and then you run
right?
it on Dataflow. But you could potentially run it on Spark as well if you want, or Flink or whatever.
Could you do Spark and Flink and still get it to Dataflow? Is Dataflow open to Beam, or is it really Beam?
No, it's
oriented?
Beam. Beam is like the way of kind of translating the code into lower operation.
I don't know shit. I don't know shit. I have some opinions about this, but I'm trying to trigger you.
I'm trying to trigger you without really knowing what I'm talking about, and it works.
No, but I think Google is really smart sometimes from a strategic point of view in defining a standard like Beam.
Totally.
Exactly.
Which is 100% compatible with Dataflow, which is there.
Which is the only language to do Dataflow, though, by the way.
It's the sales funnel that all leads to.
But then they have, they claim, they want to have a standardized approach, so people shouldn't feel locked into Dataflow, and they can have the code running on whatever they want.
But
it's
so smooth. It's so smooth to use Beam.
Yeah, but in reality, it has like 100% support for Dataflow, but it has like perhaps 70-80% for Spark, and I don't know. And less for Flink.
Yeah, totally.
So you are not going to be able to use 100% of the functionality of Spark.
And also you're really missing out you're really missing out on them if you want to really use their.
So it's a smart thing and it sounds so cool. You're not being locked in, but in reality you are, I would argue.
But let's go another way here. Help me out here. Because, so let's now talk a little bit about the core machine learning stuff, right? Mm-hmm. So how do you set up your machine learning workbench versus deploying machine learning models into code? How do you do that? I mean, where do you explore and where do you deploy?
We are relying heavily on Kubeflow and TFX now at the moment. Essentially, kind of a lot of it kind of depends on which model we're talking about here. But in general, I would say we do a lot of feature engineering and kind of selecting stuff from BigQuery, of course, because it's easy, and then that is then processed in Kubeflow. And
what is Kubeflow in this sense?
So Kubeflow pipelines. Is that what you were asking? No.
I'm asking stupid questions to learn. Okay. So is that should I understand it as a workbench?
So we're using,
data
TFX is like a lot of tooling around building TensorFlow models.
Yeah.
And then you can run that on different, and this is similar to what we said before, right? On different things. Running it in Kubeflow is one of the ways which we're using because.
So deploying, running in Kubeflow, exploring in TFX.
Yeah, exactly. So we do. You have the pipeline concept in TFX as well, and so you have the different. Different things like validating schema and a lot of those things, right? And you construct this kind of essentially DAG, right? Similar to a lot of different, like all of these systems that I'm talking about have DAGs for some reason.
What is DAGs?
So direct
execution graphs, I guess.
Yeah, exactly. Yeah.
What does that mean?
So it means do this, then that, and then
this is the instruction.
Exactly. So like this step depends on these 3 different steps, and they depend on that, and so forth. But it needs to be.
That's how you build up the workflow.
Yeah, exactly. It can't be cycles. It needs to be kind of flowing through. But that doesn't matter that much. And then you have cached kind of the possibility to cache steps, so you can kind of rerun different experiments on parts of already computed data, which is super neat. And but I think also kind of just standardizing it in order to make it easier to collaborate on is very important.
The reason I'm sort of asking the questions in a super stupid way is because, number one, I don't know better. I'm trying to learn. Number two, I think this way of understanding how to code and build systems is out of reach currently for 90% of the market, right? So they haven't moved on from an application-centric way of coding to a data-centric way of coding. So we do things in Dynamics, right? Or in SAP, right? And then we do databases. And this whole mindset that, well, actually, the workflow is kind of simple. It can be whatever web interface, quite thin. And we're building data pipelines, and we're transforming data, and we're setting instructions to do different things, which to me is some sort of, it's really already here what I would call data-centric coding. And then, of course, you can go more and more data-centric AI and all that. But even the baseline data-centric way of coding systems that Spotify and Klarna has been doing for years, I think, from the traditional companies, they haven't really, they don't really understand what's happening under the hood.
I don't think either people understand the level of quality that the cloud services provide. If they were to redo everything themselves and rebuild their own service for doing all of these kind of services, they would never be able to do anything as quickly as I guess you have in Butterbrain, right?
That was very crucial from with the start when we were 3 developers. I can have 100 machines that I need to maintain and stuff like that, right? I need more people than that just to maintain the machines.
Let's change the hard drives.
Yeah, exactly. And it's definitely a benefit being able to start from scratch like that. It's of course hard, you need to figure out a lot of things. But you don't have the legacy you don't have the legacy, so you can just kind of go for whatever you think sounds interesting. And then I was in regards to why we selected Dataflow was because I was all into that at the point. I read this. I think you probably also read it at the time, the Streaming 101 and all those kind of papers and the Kappa kind of architecture and everything. We're discussing that heavily at Klarna at the time, since we were using the Lambda architecture. And then the data flow kind of tooling and papers came out, and that kind of made me really go for it. So.
But it is super cool, and you are so deep into it, so you don't even understand that. I mean, if we talk about Google or Facebook here and Spotify and Klarna here, I mean, it's so far away from understanding. I mean, I have the basic conversation on a daily basis. What's the difference between application-centric versus data-centric development? And I'm not talking sort of AI stuff. I'm talking, should we put everything in SAP as a monolith, right?
Yeah, or in Kubernetes. Or you even talk about that.
What is Kubernetes? I'm talking about very, very traditional building a core application, financial application, and we do everything, and we build a monolith in an application layer on top, right? And we code a whole stack within one vendor's application. That's what I'm talking about. And then building, point-to-point integrations.
I guess the lesson learned basically is that if you use the awesome cloud services that we have today, you will get, very far or very quickly. It's just super unfortunate that we don't have a single cloud provider in Europe.
Yeah, that's a good one.
Exactly. Klarna started trying to build its own cloud at some point.
That is a good mission.
They should have done that.
What's happened, after you've done all the processing, you're saving the state in Bigtable, etc., in Google Cloud, and then you want to have the output to the deal team in some way, I guess.
Yeah, so we do have a web application, right? Served in Kubernetes.
Served in Kubernetes, cool.
Which is React and Node based.
So React Node based on top, served by Kubernetes.
Served on Kubernetes, and the data is served through a few different database databases. But the primary one is Elasticsearch.
Cool.
Managed yourself, or because they don't have anything?
In Kubernetes. No, exactly. No, we use it managed ourselves in Kubernetes. Yeah, exactly. Yeah.
So it's the GCP version of Kubernetes, or you're using Kubernetes native?
No, exactly. We're using the Google provided Kubernetes solution, which is
GKE.
Exactly, it's the same. Yeah, very similar.
Yeah, Elasticsearch, I think, is such an undervalued, or I think so many companies are using it now, but it's super powerful in so many ways.
And what is Elasticsearch?
Yeah, you want to start?
It depends on how deep you want to go. It's essentially a packaged kind of version of Apache Lucene. So you do kind of have a concept of indexes. So you build search indexes that can be kind of easily distributed on a lot of machines. So,
and what are you trying to achieve with it? Why is it so helpful?
So for us, it's very, very important because we do a lot of search.
Yeah.
So, but that sounds easy, but it's pretty important. I think we do serve a lot of data to our kind of deal teams, right? Not necessarily so that they will look at everything, but they need to be able to get the results quickly. Yeah. So first of all, like Elasticsearch scales really well. You can't do like joins and stuff like that, but it's like when if you have targeted searches with filters and maybe free text, then it performs really well. And that's not something that a lot of other databases can say actually.
And there's a shitload of plugins on that. You can do graph analysis and maps and
exactly
so many things. And I guess basically you're building like an interactive web app in some way using Elasticsearch as a backend where you can interactively search through things.
To me, this is so next level.
But this is what the deal teams interact with, like the most. We do have a lot of Slack integration as well, where they can kind of interact more. Exactly, and interact more and have like notifications of when a competitor receives funding.
So you have notifications coming through Slack
like
to them.
Yeah. And then, of course, they have the concept of notifications in the UI as well. But
are you automating the Slack channel, or is it something that you manually push, or you have automated those notification feeds?
Yeah, definitely automated.
Cool.
A lot is automated there. There's a lot of notifications. Some of them are too many. Some of them are.
But actually, we haven't asked the real question. You were 3 very early in the start. How many is in the team now?
We're 23.
23, eh?
Yeah.
In 3 or 4 years?
5 years since I started. Yeah, I started in February, I think. So in February, it's 5 years. Yeah.
This was an awesome tech part segment, I think, right?
I hope you enjoy my stupid questions.
No, it's awesome.
I enjoy it. I think it's great. Yeah.
I mean, it's really good.
And you need to understand, I'm literally this stupid, right? And I'm pretty smart on these topics. So, I mean, like, compared to someone who has no background in it. So it's such a divide, seriously, between the real experts. People are trying to shape the teams of the experts versus the budget holders in normal companies. So I'm the middle guy here, so trying to ask sort of half stupid questions, which is really relevant questions for me.
Kind of understanding still, but not
because it helps me to understand, so I can explain.
And let's move to another topic then. Perhaps moving from tech to academia in some way.
Sure.
Right?
Sure. Nice one.
And I really like that you actually do, in a startup of 20 people, still find the time to write scientific articles.
Yeah, that's pretty cool.
Right?
That is so cool, by the way.
If someone had told me that 5 years ago, I would have been so happy.
This is super impressive, by the way. I think it's super impressive. And it shows the way for what innovation needs. R&D proper.
And this had been accepted as well?
Yeah, it was actually presented now last week in EMNLP on the Dominican Republic by my colleague Diana.
Did you go there as well? Or
no? Okay. My colleague Diana went. So.
Oh, okay. What was the name of the conference again? It was
EMNLP.
EMNLP, yeah.
So Empirical Methods in Natural Language Processing.
Awesome.
Which is one of the big ones.
Yeah. Super impressive.
Yeah.
Okay, so the name was PAUSE, right? What does it stand for?
Yeah.
Positive and annealed, unlabeled sentence embedding. Right?
Thank you.
Yeah.
The idea with it is like we briefly touched upon it before with similarity, right? We do have a lot of similarity and kind of questions like that. And normally when you do similarity, you could do with completely unsupervised, so you can kind of try to compute different embeddings and find kind of distances between them and so forth, and that's great. But you could also do it supervised, which essentially helps you fine tune the embeddings into what you're actually after, instead of having some kind of embedding that tries to understand all language. You could kind of then start fine tuning it.
And we are speaking about text now, right?
Yes. Sorry. Yeah.
So unpack it a little bit more. So what's the fly in here?
So NLP is all about understanding text, right? Like you said.
And the use case where this...
So the use case is essentially finding similar companies as something else. Right?
Okay.
Yeah.
And
like
now we're looking at techniques.
Yes, it's applied in somewhat different areas within our models, but it's the kind of core idea is to essentially produce embeddings, which is numerical representation of the meaning of the text.
So embedding is basically a vector, a list of numbers.
Exactly. Exactly.
Can you mention how big the vectors and embeddings you have? Or?
Well, I can, but it kind of depends on which one we talk about. But it's usually like 512, that kind of style. Yeah.
We asked Spotify that.
They did not want to talk about.
We said more than 10.
More than 10, which is nothing because we knew there was going to be 500.
Anyway.
Yeah, I don't necessarily think it has to be that big, though. You could probably reduce it a lot. But yeah.
And what are we trying to do now when we are representing text as numbers and we put it in a vector? What are we trying to figure out? How is that helping us?
Well, if you represent a meaning as a point in space, if you have like 2 or 3 dimensions, like let's look at 3 dimensions, and then you can have points that are close to each other, right? And if the point represents meaning, then points close to each other in space would be close to each other.
High meaning.
Sorry?
Good high meaning, you mean? Like close to each other is good.
Well, it depends if you want it to be to find something similar, right? So if you want something very different, then they should not be very close. But essentially, what we are after is finding something that is close to the neighbors. So you could do like nearest neighbor search in that space, essentially.
And I guess it's a classical example of this is, if you take like a Paris Hilton as a person, and then you want to, if you do traditional techniques like TF, IDF and these kind of things, you just look word by word. And then Paris, that can be the city of Paris, or it can be the person of Paris Hilton.
Yes.
And to be able to properly understand the meaning, you have to look at the full context. And at that point, you really understand the meaning of it. And this is what we want to do. So then we can understand that the text is speaking about not the city of Paris, but actually the person of Paris Hilton.
Exactly.
Yeah. Just to make it very simple, right?
So the vector topic is now about understanding that this text is correlating to this type of company, which is now an interesting company.
Right. Well, yeah, exactly. So you could potentially envision this work started when we launched the growth fund. It was a new initiative. We didn't really have any labels at all, and then we kind of figure out like how should we handle this? So, like and then they could provide us with a set of deals or companies that they thought was very interesting, but we didn't really have any kind of large sets of
data.
Exactly.
Training.
So then we wanted to expand it from like using more of a similarity approach rather than just the classic kind of ranking and training on a lot of data.
And the traditional approach for doing this kind of similarity measures, I would say, is sentence BERT kind of approaches.
Yes, exactly.
Right.
That's exactly what we used before we started with this. Yeah.
Right. And perhaps you can give a quick introduction to sentence BERT as well. Or?
But BERT is a pretty advanced model, right? Using transformers essentially. Yeah. But that doesn't matter that much. But essentially, the idea is that you it's one thing to kind of compute to get these kind of embeddings. But they should also kind of make sense if you look through the space, right? So like you could potentially have a space that is kind of very local, like solving some of these kind of training issues that you would have. You could get embeddings out of like the normal BERT as well, whereas the sentence BERT tries to train on pairs of sentences instead, so that you can understand like then you essentially construct a space then that makes more sense and kind of you can extrapolate in. So like if you have some meaning over here and you have another meaning over here, then between those two meanings should be something that is between those meanings. that sentence did not make sense, but
sentence BERT in one way to describe it is if you take traditional BERT embeddings, and you want to predict similarity, it's kind of hard because normally you have to fit both the two sentences and feed that simultaneously through BERT, and then they produce a score. But that's impossible if you have thousands of meanings, because then you have to have the combination of all of them together and then sort something. So what you really want to have is a single fixed embedding for every sentence that still works when it comes to similarity
in this space. Exactly.
Right. But this is so hard to follow.
Yeah. Well,
anyway, it was hard to say as well. So
thank you.
Okay, so
but now you go for another technique now to solve.
Yeah, so what was the problem with SendSpurt? And why did you not?
There is not really any problem with SendSpurt apart from like the using SendSpurt works. It's just that in regards to the similarity that we're talking about, it's very kind of specific, right? If you have a text about a company, maybe they talk about like other stuff in that text that doesn't necessarily have to do with what the company do, right? So when you're talking about similar companies, you have some idea of what you think is the thing that is similar. Like, you don't want it to be like the funding that they have received, for example. Like maybe you do, but then you want it to be explicit about that, right? So it could be other things like just other noise in the text, essentially, where that the model picks up on as well, because it's part of what language is about. So it's still the texts are similar, but it's not necessarily a similar company. So you want to fine tune this embedding or the model essentially then to care about what you care about. Right.
So not have a generic similarity measure, but actually a similarity measure that is important for you in some way.
Exactly. Right. And that's great. And you can do that with already, that you don't need to use our method for that. The thing that we kind of provide is that you could do it in a positive unlabeled setting, which means that you only have a small set of positive labels. You train on that and all of the unlabeled instead of having like positive and negative labels.
So does that ultimately mean that the whole labeling effort goes down in this way of working?
So we managed to get like state-of-the-art performance in some of these tasks with only 10% of the labels.
So and now we're getting to what I think is some of the holy grails topics in order to make AI really fly. It's like if you're going to label everything full on. I mean, like we talked a lot about this, that's the next level, right? What the real research is all about. How do we get to the same top performance results where the AI can label for you, or you think about labeling in a different way? And I think this is...
I mean, that's one of our biggest challenges is kind of, it probably goes for everybody, but like we, compared to some of the large companies that have a lot of labels for a specific task, we do not have that. So
to actually solve the AI divide problem where they can label everything, for having normal companies without having to go through the extremely expensive process of labeling everything, we need to have techniques that works for small data sets small labeled data sets.
I think that's the bottom line, right? So labeling is an AI divide topic because the normal companies, in order for them to catch up to the thousands of people that's been labeling for 10 years within Google, it's such a start that no one can catch up with if you don't crack the code smarter.
Yep.
We need to be smarter than that.
So how do you do it?
Yeah.
So
this is a good problem to solve, by the way.
So essentially, I think, that's also, I think, why it was received with very kind of open arms in this conference, because they thought it was super interesting. And I think, and it is super interesting. And I think it also kind of relates back to the problem we have with people. But I think this is also very common. Like you have very kind of important, high-paid people, you don't really want to ask them to do the labeling, right? And it's so much easier to ask them for positive labels than negatives,
right?
Because negatives essentially means they need to go through a lot of just boring shit and then say no. But somebody who's not them can't really do it, because if I do it, like if I want to go through all these computers, when do I know when it's actually not a no? Right? It's super hard. Like
very simple. It's very simple problem.
Yeah. So that's why the kind of positive idea and the positive unlabeled kind of setting is not new either. It's just new in this setting.
What is unique or new?
So it's essentially normally when you train on positive and negative labels, you have a data set, and then you kind of have a loss function that kind of represents when you're wrong in the different ways, right? You have some kind of loss when you're wrong about positives and some when you're wrong about negatives. And essentially what this is doing is that we only use the positive side of things. And then we use the loss, construct the loss essentially for all of the data, like including the unlabeled stuff. And then we approximate the negative one by kind of removing the positive side of things, like for that. So it's like, so you need to do some assumptions in order to kind of get to that kind of loss function for the for everything, and then then you approximate the negative loss. Yeah, exactly.
And you can then now prove that the performance is still, you made your approximations, and the way you do that, in the end result is quite good, right?
Yeah, it's the same, exactly. So we start with doing it essentially with similar amounts of labels that you would do, like if you had all of the data labeled, right? And then we reduce it, the number of positive ones, like more and more, and manage to maintain the kind of performance quite far down.
And what's the ratio between labeled versus unlabeled that you actually can come down to?
We went down to, it depends a little bit on the task, but we went down to like 10% of labeled then.
So, okay, can you just go through it? So you have a set of unlabeled data points that you want to train on still in some way, and then you have a set of positive data points that you want to train in some way, and then you have to have a loss function for them in some way. And don't be afraid about going techy. Try to simply explain the best you can. How do you do this?
But it's essentially kind of I don't know how to explain it in a nice way exactly.
Don't do it nice. Do it techy.
But essentially, like if you look at the loss, right? Normally, if you have both positive and negative ones, that's the loss for the whole data set, right? So if you remove the kind of the positive side of things, you only get the kind of negative loss, right? So you could potentially then, if you approximate the entire loss for the whole data set, looking at all the data. So you train also on the unlabeled. That's very important, of course. So you need to have all the unlabeled data available, right? And then somewhere in there, in that loss that you have for all of the unlabeled stuff, you have the negative side of things. So then you can potentially, it's similar to kind of understanding, like, you essentially have like positive and negative examples. Like all of the data set definitely consists of this. So if you remove the positive ones, you only have the negative ones left, right? And there should be a loss for that part. And
how do you define the loss for the approximate negative part then, or unlabeled part?
But I think, essentially, I think it's better to read the paper in this term. But it's pretty mathematical. It's a bit weird to kind of explain, I think. But essentially, you need to kind of understand some kind of distribution between the positive and the negative in the kind of full set, right? So you need to do some of those assumptions early on, and then the algorithm also kind of. Essentially, we had some problems converging, and that's why we had this anneal term as well, because this uncertainty or assumption early on doesn't necessarily hold exactly. So then, like if we don't have the anneal term, you kind of have it's the possibility, I guess, to get stuck there because the assumption was not this actually.
So anneal in some simple terms means you basically decrease the weight of some part of it during the training. Like it's a moving like more in the beginning and then like less later. Yeah, in the space. Yes.
Does that make sense?
Yeah, the annealing part, I think. But I think me and some others are probably a bit confused still. You have a huge number, 90% of unlabeled data points, and you want to train on those. So you have some way of defining a loss for the unlabeled data points.
But it's essentially learning from, like, if you would only kind of train on this specific data instead of, this is specifically for fine tuning, right? So, but if you would only train on that, like unlabeled data, you would probably have a more fine-tuned kind of embedding to your case than you would otherwise anyway, right? Because the nomenclature in the text and everything would be kind of more geared towards your task, but you would just not be directed that way. So you definitely learn from the entire set, but then you also learn from the difference between the positive and all of them. Like so you So
are you like combining like a random part of the unlabeled with the set of positives, or how do you calculate the loss for the unlabeled and the positives that you do?
Sorry, I'm not sure I got it.
So, I mean, you have a data point in the unlabeled part of the data set, and then you need to calculate some loss somehow, and you need to combine that data point with something else. Right? Because you're using the same architecture as the SBERT, right? It's basically the
it works. It actually can work for more architectures than that. So, but we are using in our models fine tuning on SBERT.
Yeah. Are you starting, by the way, on the pre-trained SBERT, or?
Yes.
Okay, so you're starting from fine tune and then, already pre-trained.
That's what exactly. That was the fine tuning is. Yeah, exactly.
Yeah. And then you fine tune it for your use case by having positive labels. I see. Cool. Yeah, it's a lot of math as well in the paper, but I certainly recommend people to. I haven't read it actually fully, so I don't know the part of it. But
please do, and I'm happy to answer questions if anybody has questions listening as well. Like afterwards,
we can even post a link to the paper in the comments field if you help us with this, Kirill. Yeah,
absolutely.
But just a stupid question. So when you read a paper, Anders, and the math.
I did this in half an hour before.
No. I'm not referring to this case. So it's the key to really to tap into a paper and to take value home from it and be able to do it yourself, like in your professional work. Is it to really trying to understand the math which is in the paper? Is that what it's all about?
I mean, sometimes it really helps. I mean, for me at least, it's about building an intuitive model in my head.
Yes.
About
what is the logic? What is it? What are they trying to do? And what is the actual function solving it? Algorithm solving it?
So for me, it would be to try to understand what the difference is. Often it's in terms of the loss function in some way compared to the previous approach, which is the sentence approach.
So let me ask a general question now, who is not a data scientist or a mathematician. What types of math are we talking about in this paper? What is algorithms, fine, but could we be a little bit more specific? What is the type of math we are talking about?
Type of math?
I don't know. Is
linear algebra?
Is it linear algebra? Is that hardcore? What we're talking about as a mathematician?
I mean, it's always linear algebra in regards to machine learning. I think.
Okay, so that was a very stupid question.
I would have loved it to be like group theory or something really cool, but it's
categorical theory.
Exactly.
I mean, deep learning is really simple. It's about matrix multiplication and then add some bias.
Deep learning is very. I will quote you on that. Deep learning is very simple.
But it's also kind of part of that's math that is easy to make a computer to understand. Right?
Yeah, it's a computer. Okay, so what math is computers good at, and what math is computers not good at? And almost philosophical.
I mean, symbolic stuff in general is harder for computers, right? You do have engines that tries to handle symbolic stuff, but
algebra, linear.
But just kind of easy when you think about it. Like a computer is based on essentially processing arrays and matrices of numbers, which is essentially what linear algebra is about, right? So I think
it's a simple answer: linear algebra.
But you could definitely represent like other parts of math with those similar.
I mean, like you do vectors, and so in some ways you're working in another space when you start combining.
Vectors is linear algebra, but there is also this kind of calculus kind of math, with ordinary differential equation kind of neural networks.
Totally right.
That there are coming in other types of maths as well, but normally it's just linear algebra. I would argue.
I mean, it's very interesting when you
That's when a good question. I got you going. I like
when you do like stochastic differential equations and stuff like that. You still have to represent it in some way. So with operations that usually kind of end up being matrix multiplication.
It is, right? It's both beautiful and sad in some way.
But in the end, are we talking? This is more math than statistics. I mean, like statistics is something else. So where do we draw the line between statistics and math?
What's the quote about the difference between machine learning and statistics? There is, I don't recall the comment of it. It's something about I don't know what to call it. Software engineer versus statistician.
I think I've seen it, but I can't.
About,
I don't know it.
Someone that understands. I don't know.
Yeah. Anyway,
it's. I mean. Statistics is kind of also trying to, understand and describe things and uncertainty in a mathematical way, right? So, like at least probability.
But actually, I think we had our guest Anders Bresell here, who explained this quite well. He was working in AstraZeneca, And basically,
that's very important there.
He's working. But seriously, he was working in one side where he was starting to not in Stockholm work on the machine learning part, and then all of a sudden he moved and he sort of got into this. He was like a machine learning guy that got sort of stuck in the middle of the statistical team, right? And the outlook and the whole approach to the problem is very, very different. How can you have the perfect sample? How can you have the perfect population? How can you understand the context? So they're working on completely other types of problems. And he's like, that is not really important if I go machine learning approach into this problem, which is completely then, trying to understand this is two different worlds. And I think I can't do it as well as I think he conveyed that quite well. If you look at that podcast a couple of weeks back.
Yeah.
Do you agree, right? I think he conveyed a good story here.
But it's pretty interesting. I think there is definitely inspiration to take from the classic statistics as well. I think it's great with statistics. It's always like when you learn or read statistics, there's always these kind of really weird brain fuck moments. Like when you're like, what? That does not make any sense, like from a rational perspective. But there's a lot of those kind of, almost paradox examples where to understand statistics.
It's also like religion, almost like in programming, you have different languages and it's a war on religious kind of war between different languages. And I would say the same in statistics sometimes, Bayesian versus frequentists and whatnot.
Totally.
And
you have the different problems where like it's solvable in not one but not necessarily in the other, and and it's also about assumptions and where what that kind of actually affects, right?
Yeah, but I saw some sort of this. What is the deal with Bayesian? Because it's a little bit like the core example where, like, if you go from one angle, you can solve it, but if you go from the other angle, it's like unsolvable. It's this whole flip of the coin.
The idea with Bayesian statistics in general is that you have some kind of prior knowledge.
Yeah,
right?
that's the whole point. If I remove the prior knowledge, you shouldn't know anything. You need to.
But it's still mathematically possible to kind of come up to a certainty. Then, if you don't know something, then you can still represent that as a distribution.
Yeah, but here's where religion comes in. That if you have the knowledge.
No, but like L2 regularization can actually be seen as an equivalent part of having a prior as well. But I think a difference.
There is like Bayesian logistic regression as well, which does essentially the same thing, right?
Yeah. But still working with distribution in general, I think is a big difference when it comes to Bayesian kind of reasoning.
You have this German tank problem. It's like a very known type problem where Bayesian statistics is nice, right? Where you where if you give in a serial number, like say that you have like 2005, then like how certain can you be about how many tanks there actually exists? Right. That was actually kind of World War II kind of problem that they needed to use Bayesian statistics.
And just to reveal how old I am, but when you say Bayesian networks, so many people think Bayesian neural networks, which is completely different from traditional kind of Bayesian networks that actually had probability theory as the core reasoning mathematics. And Bayesian neural networks is just a gradient descent with a distribution of weights.
Bayesian networks is more like probabilistic graphical models, right? Or similar to
which one you mean? The Bayesian,
the first one,
Bayesian networks. There is no weights in that.
No, exactly. Yeah.
So the nodes is just conditional probability tables.
Exactly. Yeah.
And then they have proper probability rules. So then you have proper probabilities in all the parts of it, whereas neural networks, of course, is just an approximation.
It's more like mathematical reasoning. And what happens if you know one value, then the distribution changes due to something else.
Super cool stuff, really beautiful, but completely useless.
But it probably depends on which problem you're kind of...
I exaggerate a bit, but it doesn't scale for large pieces of data.
It doesn't scale.
That's the problem. Otherwise, I loved it. I actually spent years with that for like 20 years ago.
I did use hidden Markov models in a bit. That was just like a simple example of that, right? Yeah. It's pretty cool stuff.
Okay, we are digressing. So
yes, and the time is flying away.
I love it, by the way.
What's up in the future when it comes to Mother Brain? Anything you can share? What you're working with right now, or what the more long-term plans are?
And I think in general. What we try to do is just kind of meet the deal teams where they want to kind of improve and be more kind of data driven, right? So we are looking to do more kind of experimental kind of things with them, understanding more potential different use cases that we could apply AI to, expanding also to more business lines. So we're like, for example, the infra and the real estate parts, we haven't really kind of gotten our teeth into that much yet. So, yeah.
I mean, exactly. But still you're keeping like the EQT kind of funds as the core customers, or are you thinking about expanding outside of EQT as well? Or?
That was my question.
Oh, sorry.
I was going to ask exactly this.
I think
good one.
The
great mind think alike.
Yeah. I mean, the primary idea with our tool is to make our investments better, right?
Yeah.
That's the kind of primary. That's where it pays back the most as well. Like having some few payments.
So this is a competitive advantage for EQT. It's not something you're thinking about putting on the market. That has not been the strategy. No, so you're going to kick ass in the market.
It's also not been the strategy when kind of acquiring data legally, right? Then you need to really. It's definitely doable, but you need to completely kind of you need to redo everything then in that sense. So, yeah. We have been discussing maybe trying to make it available for like portfolio companies, which could potentially make them smarter as well, right? That would be super cool.
You are there to make the idea of what you are there. Motherbrain is there to make EQT smarter. That's the core. Yeah, that's the core. That's the core. I like it.
Brain of EQT.
Motherbrain of EQT.
So I'm trying to avoid going to the more classical kind of philosophical topics here, and we should find another angle.
Let me ask you a question. What is your sort of, do you have any passions or hobbies or something like that, which is sort of data or sort of math related or something, or completely different that is sort of a big part of who you are?
I mean, you must consider that I'm a dad, having a 3-year-old and a 6-year-old. Yeah, that's definitely my hobby. And as I mentioned to you guys before, I'm also like the football coach, right?
So now you have a new, you can start putting something on your CV quite soon now.
Yeah, exactly.
Yeah, well, what coach, right?
Football coach as well. And then the synthesizer interest is obviously taking a lot of kind of effort and time.
But football coach.
The football coach.
We do 2 minutes on football coach.
Yeah. So my daughter plays football in Täby, where we live, and then I mean, I just realized that I was a very, very active dad, standing on the sideline and like screaming and you know,
I've been there,
in the best possible way. I just think I was very much more kind of engaged than anybody else. And then she actually asked me like, why don't you want to be a dad, like a coach?
That's
and hard. I was like, yeah, maybe I do actually. Like,
but connecting that to becoming a coach in some way is interesting. You have to have some kind of more people skills in being able to do that, and potentially it also connects to how to run a company in some way. And you want to scale up, and you want to. I'm not sure if you
managing kids is definitely harder than
leadership of kids.
I'm not sure actually.
No, just mostly joking. Yeah.
But what do you think about, how it's one thing to coach the football team with your kids, etc. And it's another thing also potentially, or it could be the same, to manage a startup and to manage a team of data scientists or have like a cross-functional team that can deliver quickly.
Totally.
Do you think there is some kind of learnings you can do by being a football coach that you can apply for how to run Motherbrain?
I hope so. I mean, I think one of the things that I think is the most important in leading a team, and I mean, it's slightly different depending on the company structure and stuff, right? But it's like getting a really nice culture where people feel safe and then they can kind of, be themselves. Because somebody that is happy and kind of feeling secure and kind of having fun together, solving problems, that's super powerful, right? And I think that's very common kind of to what you do when you're playing football as a team, right? You need to work together, you need to have fun, you need to feel secure, you need to know that somebody else has your back.
I think that statement is profound. I've been a soccer dad coach for a while with and
then you're so much more experienced than me.
Yeah, I am, man.
I'm a bit afraid now.
But so my boys are now 15, 13, and 11.
Yeah.
And my oldest guy, I started with them, and 5 years old, right? And the main thing that is a learning curve for you as a soccer coach is that when you look at it at a team of children, right, and they are maybe 8 to 10 years old. You have some of the guys or people in the boys or girls in the team, which are sort of super cocky, and they've been playing football their whole life, and they just dominate, right? I mean, like, because they have some skills, because they played when they were 3, right? And then you have some other kids on the court that at that point in time hasn't really touched the ball so far, so they're a little bit insecure, and 80-90% of the performance of the team is in the head, right? That, I'm not so good, so I don't really want to participate. I don't even want to try, yeah. So you see half the team is running like hell. It's especially funny when they're 5 years old and they're
my daughter is 6.
6, but they're like a swarm, right?
A swarm around the ball.
But then you see a couple of the kids, they're not participating. They're spectators. And in reality, I had a really profound understanding looking at my children, which are very, very different, right? And in terms of how their progression in sports has been. My middle son was for a long time, both in football and floorball. This is a long rant now, but I think it's important.
I love it. I'm learning so much.
Yeah, but he was a little bit like, didn't really care, likes to play games and like Minecraft more. And for a long time, he had really low self-esteem because he didn't have the technique right. And I was trying to say to him, like, look, man, what everybody's being frustrated is if you don't try. If you go out and work like hell, and if you are the pain in the ass, so the competitors or like your opponent can't come, if you lose the ball, they fool you, but then you run like hell to take the ball back. Everybody will have full respect. And then you do that and you go to every training, your technique will improve. And then he turned, like, he's now 13. And this was a massive shift like 2 or 3 years ago in floorball, where I could see when a little bit like he's running half-ass after the opponent or trying a little bit, but only a little bit from the side. And something happened where he basically decided when the ball is running down that, I am the guy who's going to be first in the corner on that ball. I don't care. I mean, like, so the mindset shift to it's my ball. It happened somewhere 2 years ago. And that's then his progression in terms of sports, like, and I talked to his coaches. I was coaching him when I was younger and not anymore. It was really a spike, right? And what is the core lessons learned? It's to have, I'm getting goosebumps from all speak now because it's a little bit like, it's down to creating the trust in each other and the trygghet, safety, the safety in the team that we can talk about everything, the safety in the team to try, the safety in the team to innovate and try and do your best, fail and go get and everybody. And if you don't have that safety, and this is a profound connection then between innovation and teams and kids and sports, in my opinion.
Yeah.
Huge.
Yeah, I totally agree. And I mean, just feeling safe enough to be able to fail things is like super important for innovation, I think. And my old boss, Daniel, was really clear on this, I think. And I mean, he set the culture in our teams to be that, like, early on, like a very safe space where we're allowed to kind of pursue things that we think are interesting, and also kind of sharing failure and being kind of proud that we tried. I think it's great.
But we talked a lot about how important it is to infuse R&D and innovation in companies. And right, and we've seen it, like all the big tech giants, they're putting huge money on this. But maybe this is also a mindset topic, to have the culture to fail fast and all this kind of stuff, and and that means safeness to fail in some.
Perhaps one question that we could try to phrase is, what is leadership to you? And leadership, I don't mean like having the managing responsibility, rather than actually being someone that can be a role model or actually be someone that mentors other people to make the best of their potential, so to speak. And that
I think that's essentially what it is, right? Yeah. Facilitating that possibility. Yeah. That's definitely super important. I think it's both kind of creating the space where people can try, and also kind of giving them recognition when it happens.
Right.
I think that's super important, and sharing the wins.
Do you think that applies also in Motherbrain in some way, or just in general for building teams that are successful? How would you build that kind of self-esteem, I guess, or the idea that you can actually, I guess, fail?
The safety, I think, is...
Yeah.
I mean, we've done a lot of things, I think, over the years that doesn't necessarily fly, right? Mm-hmm. I think you have to do that. I mean, you have to try things, and it's a great idea, I guess, in some sense, but it just didn't really translate well to how other people think about the problem, or it didn't really work out in the first place, right? I think that's super super important. Sorry, I kind of lost your question a bit now.
No, I'm trying to think. I would argue at least that especially in data science, and if you want to have some kind of agile kind of mentorship or leadership, you need to have people that have the courage to take their initiatives without fearing the scrutiny, I guess, of some kind of boss or someone that is going to punish them for taking initiatives. And
I think it needs to even be encouraged, right? That you do take initiatives. Like I think the worst kind of culture that I think you can foster is that you're like have to do it in a specific way, and you're not really allowed to think outside of the box, because that's like obviously then it's not something that someone that is interested in a subject would thrive in, right? Because they need to kind of think about problems, innovate, kind of try something, and that's what drives them and that makes their work like interesting to them, right? And I think that needs to be the general kind of culture in a team, especially in a team that has to innovate a lot anyway, right?
And I think that's especially true in AI. And sometimes we've spoken about the difference between AI engineering or building AI-based systems versus traditional software engineering systems. Yeah. And trying to build a mobile app, that can be challenging, of course, in itself. But I would argue the more data-driven an application becomes, the more
experimental you need to be.
The harder it is to predict if it will work or not. You have to be experimental. You have to do a lot of experimentation, and you never know until you tried it with the data you actually have if it will work or not.
No, exactly, because it's harder to guarantee that, because you kind of have an assumption to start with rather than the other way.
But I argue you're touching now one of the core problems or root causes why corporates have a hard time to innovate, because their core steering model, budget model is plan-driven. And it has all to do with that they are in the mature life cycle of whatever they're doing. And then you're relying on plan-driven approaches, supply and demand, right? How many trucks do we sell? How do we plan our production, right?
For the next year.
Yeah, for the next year. And basically, they have forgotten what it was to be a pioneer 100 years ago, because they have the data and the trend and the way we set budgets now. People are doing all these elaborate ideas of how you budget and plan, but someone at head office could basically say, I say 5% up or 5% down due to macroeconomics. And from a plan-driven economy, they will actually be quite accurate on this. Now, to take that culture and model into hypothesis-driven steering, that, I'm starting a project and I now need to have a systematic approach to fail fast and cheap. But I need to have a funnel of crazy ideas, and I need to have a systematic approach to do that, because to be completely crazy will not work when you have all these constraints of the corporate.
And if you don't fail fast with having crazy ideas, you will lose a lot of money.
You will fuck it up, right? So, and the problem now is that the big corporates are going plan-driven into these topics, and they spend huge amount of money on wild goose chases, whereas a couple of simple questions and a good lean startup venture cap model would have killed those ideas fast. So I think this is you're talking about the core models that I'm trying to implement in the companies I'm working with right now, which I think now is a prerequisite to get the arena to succeed?
Perhaps one last question before we move into, the final question would be, Motherbrain today tries to identify companies that are successful in some way with whatever indicators and signals you can find. Do you think there will be a point in the future where you can switch that question to say, I have this company, I want to make you successful.
I want to generate a startup from
No, not really. But let's say you invested in a company.
Yeah.
And you now want to guide them and make them successful because you already made the investment.
Yeah.
And you want to identify, why, like 1 year later, it's still not proceeding. It's not succeeding in some way. Could you potentially use AI to guide or understand?
Totally.
You think so?
Yeah, totally. And I think we're partly already doing that. Like it's the kind of EQT business model in general is to be an active owner, right? So kind of help the companies become great over the owning period. And continue to be great after that. So we kind of, sell it to someone else that will kind of also think it's a great company. But and I think part of that is like, of course, identifying companies that are good early on. But then, like during the holding period, you can do so much more. Like that's definitely something that we can expand on more as well. But in general, just kind of having a understanding for the space around the company, like what other companies are doing the same thing,
right? And learn from them.
Yeah, exactly. Learn from them, right? Like how is kind of trends moving over time, and what kind of are other investors doing? Like we put all our money on, or not all our money, but some of money like into this startup, right? And really thought that they would kind of become something, and then suddenly we see that a lot of money is going into someone else doing something that's super important information, right? That's being part of the whole thing. And I think also helping out in potential kind of benchmarking and how they are growing, right? When you own the company, you get a lot more data about how they're actually operating internally, and then you can also kind of use that data to compare against other companies, like how they're doing, like are they putting enough on sales or development, or how could they kind of steer towards the goal that they're going to.
Because what you're talking about now is the trajectory of growing the Motherbrain feature set or service is on the one hand side into different types of investment categories, and then on the other hand, following the investment life cycle.
Yes.
Yeah.
I mean, we have traditionally been very kind of early in the cycle, but also from the larger funds, like when we're talking about buying companies of like a billion or something, right? They're pretty big. So then there is not that many companies that you could potentially source, right? So the sourcing gets a little bit less important.
That's a life cycle.
But the diligence, like up to the actual deal, is still super important, and being fast and accurate about that, and kind of essentially kind of understanding whether or not to invest in the company is still super important. And then also, as you said, like the owning period and the life cycle.
Yeah, I guess we could continue for a long time more, but time is out and over. And I guess the next question is basically, William, what's next in your life? What's happening? I think you answered it partly because you're working or
it's a new
learning.
Thing. Like you had a lot of experience. I don't know. Yeah.
So the synthesizer and the football coach and whatnot. Do you have any? How are you going to progress with the synthesizer? What's your plan to become a grandmaster in?
I would want to get at some point actually produce a song, right, and not just noise.
We start that journey right after. Let's start now.
I think you should have answered. The best way to become better in a synthesizer is to join the after work in.
Yeah, of course,
right?
of course,
because that is what we're going to do.
If I knew this, I would have asked you to bring your kit.
Yeah. Maybe next time.
Yeah.
Cool. Anyone that you would recommend to join this podcast that you would like to listen to here?
Sorry, I'm drawing a blank now. I kind of had it prepared, but I don't know why. It's just kind of lost it.
No worries.
I'll get back to you on that.
Yeah, sure. But what do you think? More tech people, because we have this kind of balance between should it more be business related people, or more tech people, or more academic people, politicians.
I mean,
that would be super interesting. I think.
Yeah.
also from a kind of a sustainability angle, like what's happening in the world now, like how can AI kind of potentially help in driving sustainability change and kind of improving the world? That would be great.
Sustainable development kind of thing.
Yeah.
I hear Matthias Lindahl is coming soon. Yeah. Okay. Awesome. Vilhelm, it's been a true pleasure to have you here, principal data scientist in EQT, and so many interesting topics here in trying to use AI together with humans, right, to really bring the best of AI.
And I loved it, eclectic, synthesizers, leadership, nerdy papers handing in math stuff.
Yeah. Yeah, and some engineering stuff.
And some engineering stuff as well. But actually, tech stacks and then the math.
Yeah, I'm eager to go to the after work now. Yes. So let's close it. Yes. And thanks once again. It was a pleasure to have you here.
Thank you so much.
Awesome. Great. Thank you very much.
Here. Yeah.